Very good evening, my dear GW soldiers. Very good evening, very good evening, very good evening. First of all, kindly let me know audio video clear. Yes, DJ, very good evening. God bless. KTG, CSC, Sham, Vaishali, each and everyone, God bless. Very good evening, very good evening. How are you all? DJ, कैसे हैं? KTG, CSC, Sham, Vaishali. So without wasting a time, we are going to start file organization and indexing part 4 today. And my dear student, what we discuss in today class, we will discuss all complete indexing concept and B and B plus tree. Okay, bachcho. So yes, Seema, good evening, beta. In B and B plus tree and indexing concept, we will discuss, bacha. Good evening, DJ. Good evening. So what we done till now, we discussed the spanned unspanned organization. Default is unspanned organization. Default is unspanned organization, and we have a ordered file and unordered file. Ordered file, what is the cost? What is the cost? Ordered file, log base 2 B. In unordered, average case B by 2 and worst case is B, my dear. Worst case is B. That we discuss. After that, we discuss the indexing, primary index, clustering index, and secondary index. What is the role of primary index? What is the condition? Search key should be primary key plus ordered file. We can write on new page. Primary index. Bachcho, Seema, Sham, Jaideep, Gate EG, CSE, Vaishali. In the last class, I have taken indexing in complete depth. You enjoy, you watch. If you miss this session, you watch the recorded also. Seema, we have a primary index, clustering index, and third one is secondary index. Secondary index. And what is happening in primary index? Search key should be primary key plus ordered file. Plus ordered file, bachcho. Ordered file. Clear, everyone? And clustering index, search key should be known key plus ordered file. And here search key either known key, I told why, and or candidate key. Or candidate key, my dear, plus unordered file. I discussed these points. It's just a quick recap, bachcho. Clear, everyone? So this we discuss कि if it is a ordered file, then either we have a primary index, or if it is known key, then we have a clustering index. And if it is unordered file, then if it is key, then secondary index over key. If it is known key, this is DB, then secondary index over known key, my dear. So we discuss how we apply this index also. We discuss that example, clustering index. Then primary index, I told ki sparse and dense, but mostly sparse. Mostly sparse. Then we discuss this numerical also. And at most one primary index is possible. And we discuss this numerical. After that, clustering index may be dense or may be sparse, bachcho. I told, and at most one cluster index is possible. That thing we discuss. Clear? Then we discuss secondary index. Secondary index always dense. Sir, what is the meaning of sparse and what is the meaning of dense? For a sparse, index entries create for some search key values, and for a dense index, index entries create for every search key value. Then in a dense index, how many number of index entries? Equivalent to number of DB records. And in the sparse index, number of index entries equivalent to number of DB blocks, database blocks, my dear. We discuss these things, and after that we discuss the numerical on the secondary index. And secondary index always, I told, dense. And secondary index you can apply already if we have a primary or cluster index. Crystal clear, everyone? Mean to say, I told when primary index, then you can apply secondary index. Yes, If there is a cluster index, then you can apply secondary index. But when there is a primary index, you can't apply cluster index. When there is a cluster index, you can't apply primary index. Clear everyone? Each and everyone clear? After that, we discuss the multi-level indexing. We will do that process until all index entries are fit into one block. All index entries, this is the quick recap. All index entries fit into one block. Clear bacha? So what is the total number of block axis? N plus 1. And at each level number of index, at each level one index block and one for data block. If there are three level, then total block axis is 3 plus 1, 4 beta. Why? Each level one index block and in the last one data block. Like same question we done with the help of multi-level indexing. And when it will stop? When your index fit into one block, one index block. So here you can see at the third level you required only one index block. So how many levels are required total? 3 levels are required. And if there is a 3 level, then total number of block axis is how much? 3 plus 1, that is 4, my dear. Clear bachcho? After that, we discussed this question already. And this one I given as a homework. So please let me know what is the answer for this one. Then we are going to start. Yes, Sham, Seema, DJ, Vaishali, each and everyone. Please let me know what is the answer. Bacho, tell me fast. Each and everyone. Tell me fast, bacho. It is mentioned 16,384. Mean to say 2 raised to power 14 record. Each record is 32 byte. We will read the question first. Each record is 32 byte. Although record size is not required because it is secondary index, so dense. So not record size is required and it is asking with indexing. Key is 6 byte. The file is ordered on a non-key field. Ordered on a non-key field and the file organization is unspent. The file is stored in a system with the block size of 1024 byte. The block pointer size is 10 byte. Secondary index we apply bachcho. Now listen carefully. Write down all the datas. All the datas. Listen. Number of records 16,384. That is 2 raised to power 14, my dear. 2 raised to power 14. Key size 6 byte. And block pointer 10 byte. Block size 1024 byte. Secondary index. This is mentioned. Yes or no? Secondary index we have to apply. And what is asking? What is the number of index block in the first level and second level? Clear बच्चा? Sham, Seema, Jaideep, Adyaraj, each and everyone. Clear hai? Now please, first of all we will solve each and every data. Take each and every. First of all we calculate block factor of index file. So what we do bachcha? Block size, that is 1024 byte divided by key plus block pointer. Floor value. Yes or no? So you can write in the power 2 raised to power 10. 16 means 2 to power 4. 2 raised to power 6. 64 index entries per block. 64 index entries per block बच्चा. Seema, DJ acknowledge beta. And this is dense index secondary है. So total number of index entries is how much? Total number of index entries is 16,384. Mean to say 2 की power 14. Why? Because equivalent to number of DB records. Number of DB records. So what you can calculate? Total number of index block at first level. This is called first level, na? 16,384 divided by 64 का सीलिंग 2 raised to power 6 divided by 14 to की power 6. You are getting 2 की power 8. 256 index block. This is your first level. I told original file is called first level, my dear. Original file is called first level. Now, second level, what happened? This is first level. Second level, what happened? Total number of index entries. Now you create a sparse index. Total number of index entries is whatever number of blocks in first level. Now that become entries in the next level, my dear. That become entries in the next level. So now what is the number of index entries? 256. Mean to say number of first level index block. Because now you create a sparse index. I told beta in a multi-level indexing, you create a sparse index. Here I mention you create a primary index, a sparse index, first level, second level, third level, and so on. So here you are getting, like here I also done na, you are getting first level 442 blocks. Now next level it become entries. Now you are getting 7 blocks. In the next level you are getting this become entries. 7 become entries. Similarly here. So total number of index block is how much? Second level index block is 256 divided by 64. कितना आएगा? 4 index block. Clear everyone? Chamka. So what is your question? First level and second level. So C is the correct answer. C is the correct answer, bacha. 256 and 4, my dear. 256 and 4. Clear everyone? Sir, this question stop here? No. It will go to the next level also. It will go to the next level also. Third level. So at third level, total number of index entries is how much? Total number of index entries is, you will get the answer here. I'm not denying that you are not getting the answer here, but I want to take this question completely. So next level, what is the number of index entries? That become 4. Mean to say number of second level block. So total number of index block is 4 divided by 64. 1 index block. So we stop here. No further level indexing. Why? When we do this process, still all index entry fit into one index block. Why? You know the similar concept of multi-level paging. Till page table fit into one page frame size. Yes or no? Here when we stop, when all the entries fit into one index block. So total, how many levels are required for this question? Total 3 levels are required. First point, total 3 levels are required, and to access a record, average number of block access is how much? Using multi-level index. Using multi-level index. N plus 1 at each level 1 index block. Now these are some other things which I explain here. Each and every one crystal clear? Please let me know each and everything is completely crystal clear. If yes, then kindly write down chat box. everyone. Thank you, Gate EG, CSC, Sham, Seema, Jadip, Adhyaraj, DJ. Now, this is static multi-level indexing, but what is the problem in the static multi-level indexing? You know what is the problem in static multi-level indexing. You know the concept. Key problem. What is the problem in static multi-level indexing? We have overflow and underflow situation, and then we go for if AVL tree. AVL tree. You know the tree concept. Tree is what? Tree is what? Whatever you find in the garden, anything. Then what is the meaning of binary tree? Binary tree is a tree which has at most degree 2, either 0, 1 or 2. Maximum child is 2. Then we are getting BST, binary search tree, in which right subtree and left subtree have some condition ki root se bada, chota, this type of condition. But what is the problem in binary search tree? If we are getting ascending order or descending order, then we are getting right skew tree or left skew tree. Are you getting my point? Then we go for AVL tree. AVL stand for 3 scientists you know, and my big brother Pankaj Sharma sir explain in a very beautiful manner these all things. Aldenson, Welsaki and Ledin. In this we have a balance factor, height of left subtree minus height of right subtree. In balance factor must be either 0, 1 or -1. If not, then you will do perform the rotation. LL, RR, LR, RL. है ना? But then B tree and B plus AVL tree also hold one node, one keys. That's why we go for B tree. B is not a binary tree here. B is here balanced tree. B is here balanced tree, my dear. Balanced tree. Balanced tree, my dear. Balanced tree. And this B tree you read in data structure and algorithm and DBMS as well. DBMS you will find the capacities related terms, and DBMS and data structure algorithms you will find all the conceptual things also, but I will also explain here. So but before this, each and everything is crystal clear. Kindly write down in chat box. Kindly make a heart or any emoji my dear. Please let me know fast. Now, listen carefully. What happened in B and B plus tree? What happened in B and B plus tree, my dear? What happened in and B plus tree? Bacho, again I am saying, I am trying to explain each and every concept in complete depth. Whatever planner, I already increased the classes. If I find ki I have to increase the class timing also, like last class I have taken for 2 hours. 2 lecture in a one day, and today we will finish these things. Hai. But believe me, I have given each and every important concept to each and every student in free of cost. Although PW provide quality education at affordable price also in a paid batches, but if you want only from YouTube, then I trying to give each and every concept whatever is important for you in a easy and crisp manner. Yes, yes, bacha. Yes, Seema. Now, listen, B and B plus tree. What is the beauty of B and B plus tree? In the B and B plus tree, all trees are start from top to bottom. But B and B plus tree, we insert from the leaf. We insert from the leaf. Yes. Yes, Sima. We insert from the leaf. Then we split. Any bottom to top. Okay. Now, in the B and B plus tree, I am explaining first of all data structure and algorithm B tree. If your order is 5, then you let me know, Seema beta, if your order is P, then what is the maximum element, data structure and algorithm term, maximum element, and what is the minimum element you can insert? या मिनिमम कीज? टेल मी. अनुष, थैंक यू बेटा. टेल मी बच्चों. Very good. So listen carefully. If your order is P, if your order is P, okay, P minus 1. If your order is P, then maximum element you can store P minus 1 and minimum is ceiling function of P by 2 minus 1. Ceiling function of P by 2 minus 1. I told the concept of floor and ceiling. You know it very well. For example, if my order is 5, if my order is 5, then maximum keys, how much I can accommodate? Maximum keys 5 minus 1 means 4 element I can insert, and minimum keys 5 by 2 ceiling function minus 1. 5 by 2 ceiling function is what? 3. 3 minus 1, 2. Clear everyone? Each and everyone clear? You know this concept? Each and everyone let me know fast please. बच्चों जल्दी बताइए. Everyone, everyone, everyone. अनुष क्लियर है बेटा? Seema, only clear you are reading this topic first time beta? Seema. Not crystal clear? Okay, okay, don't worry beta. I will start in that manner. If you are reading first time, I will start as a beginner also. Don't worry bacha. Don't take attention. Give me 1 minute. Give me 1 minute beta. Listen carefully. And Anush, you also reading first time? You also reading first time? Okay. Listen carefully. Now we are going for B and B plus tree. This is what dynamic B and balanced tree. It is used for dynamic multi-level indexing. Static multi-level indexing we done, but what is the problem with static multi-level indexing? Overflow and underflow you can say, है ना? Because if some record entered, या some record insert, या some record delete, then each and every level, if you have multi-level indexing, each and every level you have to suffer. Now we are going for dynamic multi-level indexing, that is B and B plus tree. What is the meaning of B tree? It is called balanced tree. It is called balanced tree. Anush, Seema, it is called balanced tree in which we have a one order. What is the meaning of order? I will let you know, don't worry. Order, if order is P, then what is the maximum element? Element is called in a technical term keys. Maximum keys is P minus 1. And what is the minimum keys it can accommodate? Ceiling function of P by 2 minus 1. Okay. If order is 5, then what is the maximum keys? 4. And what is the minimum keys? 2. For example, if we have a data like 1, 5, 3, 7, 9, 11 and order is 5. Order is 5, my dear. Order is 5. Then what we can do? We can insert 1, 3, 5, 7. Order is 5, then what is the maximum keys? What is the maximum keys? 5 minus 1, that is 4. What is the minimum keys you can write in an internal node? When you insert 9, yes, yes, great, great. When you insert 9, then what happen beta? What happen? 1, 3, 5, 7, 9. Now it violates the B tree definition. It violates the B tree definition, my dear. It violates the B tree definition because if your order is 5, then maximum how many element we can insert? How many keys it can accommodate? That is how much? P minus 1. That is 4 beta. That is 4. 5 minus 1, 4. Now, what happen here? Middle become the parent. Yeah, root. Middle become the parent. Yeah, root, my dear. This is your data structure B tree. And here 1 and 3 will be here. Getting beta? Clear hai? Anu, Sima, what I am telling, if your order is P, listen carefully, my dear B tree. If your order is P, then what is the maximum element we can insert? P minus 1. And what is the minimum element we can insert? P by 2 minus 1. What is the meaning of order? Order indicate what? I will let you know, don't worry. I will explain again, don't worry. Now, if order is 5, what is the meaning? Ki maximum 5 block pointer we can have. 5 block pointer we can have. 5 block pointer we can have. Order max indicate what is the maximum number of node, maximum number of childrens it can accommodate in the next level, it can contain. Just wait, I will show how to draw a B and B plus tree, then I will let you know. एक चीज बताऊंगा, don't worry. If order is 5, then maximum keys is 4, minimum keys is 2, my dear. For example, this is the B tree according to the DSA algorithms. Now listen carefully. If your order is P, what is the meaning? If we have P block pointers, and how much keys? Maximum P minus 1, and how much read pointer? P minus 1. We have a pair of keys plus read pointer, bacha. Now listen carefully. Sir, what is this? I am not getting, sir. For example number 1, if your order is 2, then we have a 2 block pointer, 1 key and 1 read pointer. What is the meaning of this? K1 R1 and 2 block pointer B1 and B2. B1 and B2. Beta, if you are a first year student, then please don't watch, because already I have taken. Anu, sorry beta, already I have taken these things in complete depth, indexing concept. So please, if you are able to getting, then attend, otherwise don't worry. Order is 3, then what is the meaning? 3 block pointer, 2 keys and 2 read pointer. K1 R1, K2 R2 and this one. These are the 3 block pointer. These are the 3 block pointer, my dear. These are the 3 block pointer. If your order is 4, what is the meaning? 4 block pointer. It can accommodate maximum 3 keys. And for that keys, we have a read pointer. P1, K1 R1, P2, K2 R2, P3, K3 R3, P4. These 4 block pointer, bacha. 4 block pointer. Clear everyone? And if order is 5, then how much block pointer? 5 block pointer, 4 keys and 4 read pointer, beta. These are called 5 block pointer B1, B2, B3, B4, B5. Seema, are you getting? Seema, GATE, EG, CSE, each and everyone, are you getting? Getting, bacha? Now, if order is P, then what happen? P block pointer, maximum key is P minus 1 and read pointer is also P minus 1, bacha. Maximum keys. So what I am telling, if we have a B tree, if we have a B tree of order P, then what happen? It have P block pointer, P minus 1 keys and P minus 1 read pointer. Beta, in a data structure and algorithm, we focus on element. है ना? Here we focus on block pointer. If order is P, then what is the meaning? कि it can accommodate maximum P block pointer, means it can have maximum P childrens. बच्चों, P childrens. So what is the scenario? If you have a order P, then what is the scenario? We have a B1 block pointer 1 K1 R1, B2 K2 R2, B3 K3 R3, BP minus 1 KP minus 1 RP minus 1 and BP. This is the scenario, my dear, of order is P. For example, now again come here. If your order is 5, my dear, order is 5, then what is the maximum block pointer? 5. And what is the maximum keys? 4. And read pointer is 4. You create this B tree. Now I am again creating same B tree for this question. But now I am explaining here some terms. What is the some terms? Please look at the board, my dear. Look at the board. Everyone look at the board. If order is 5, then what is the meaning? Bachcho? We have 5 block pointer maximum B1, B2, B3, B4, B5. 5 block pointer. अरे वाह, great. So Anush, God bless you, bacha. And this complete playlist, Anush, we have. And believe me, if you watch this playlist, definitely you watch this playlist. You watch the recorded sessions also, Anush. So if you watch this playlist, definitely it will very helpful for you for understanding and learning the DBMS concept in a complete depth. I am trying to take each and every concept. Now here, what is the meaning of B1, B2, B3, B4, B5? Please listen carefully. What I am saying, please listen carefully. I am discussing B tree. Once again, I am telling what is the meaning of B tree. If in a B tree, it is used for dynamic multi-level indexing. If in a B tree, we have a order P, then what is the meaning? Maximum, we have a P block pointer, P minus 1 keys, P minus 1 read pointer. We have a key plus read pointer pair, that is P minus 1. And what is the minimum? P by 2 minus 1. Sir, what is the difference between block pointer and key for a layman person? You can assume block pointer is one more than the key. Like if order is P, then what is the maximum keys? P minus 1. So what is the maximum block pointer? P. Whatever is order of B tree, that is the order of block pointer. For example, here I mention if order is 5, then maximum keys is 4 and maximum block pointer is how much? 5. And minimum P by 2, ceiling function of P by 2 minus 1, my dear. Ceiling function of P by 2 minus 1, my dear. Clear? Like order is 5, then what is the maximum block pointer? 5. Keys 4, read pointer 4. This is the normal B tree. Normal means without block pointer. Without block pointer, like you discuss in data structure also. But this type you rarely found. So this is the actual B tree. If order is 5, order is 5. That means 5 block pointer, 4 keys and 4 read pointer, my dear. 4 read pointer. Now here listen carefully. What is the role of block pointer? Block pointer indicate those element. What is the role of this? What is the role of this, my dear? Please listen carefully. आपने ये ड्रॉ भी किया होगा. What is the role of block pointer? B1. What is the role of block pointer? B1. What is the role of block pointer? B2. B1 point, listen carefully. B1 point, those element which is less than K1. Which is less than K1, my dear. B1 point, those element which is less than K1. Clear, everyone? Clear? B2 point, those element which is greater than K1 and less than K2, my dear. Chamka, everyone? KTG, CSC, Shama, Anush, each and everyone crystal clear. So I discuss कि if order is P then maximum P block pointer P minus 1 की. बच्चों acknowledge कीजिए. क्या chat work नहीं कर रहा क्या? Everyone please let me know fast. Clear है? Now you have a question, sir. Vijay sir, if you take odd order then easily you are getting. If we take even order. If we take even order, then what happen? For example, sir, order is 4. Okay, sir, if order is 4, then we came to know what? We came to know block pointer is 4, maximum keys is 3 and read pointer is 3. Now same data 1, 5, 3, 7, 9, 11. Okay, bachcho. Now what we do, sir? What we do? Which one is the middle element, sir? Now we have a 1, we have a 3, we have a 5. When 7 will be insert, then what is the scenario? You are getting 1, 3, 5, 7. Now, sir, which one become parent ya root? Which one become parent ya root? Which one become parent ya root, my dear? Which one become parent ya root? Clear? Now, you have a two choice. My dear. You have a two choice. Either you can do the left biasing or you can do the right biasing. Left biasing or right biasing, my dear. You can do the left biasing or right biasing. Mean to say, either you can make 3 as a middle element, then you will write here 1 and here you will write 5 and 7. Or you can make 5 as a middle element, then you write 1, 3 and 7. Clear, everyone? Clear? But what is the main thing which you have to keep in mind? What is the main thing which you have to keep in your mind? If you do the right biasing, sir, what is the meaning of right biasing? Biasing means what? Biasing means what? Just a minute. Listen carefully now. Each and everyone. You have a one doubt. Ki sir, Vijay sir, you are taking order, odd order. Odd order means easily we can find the middle element. Easily we can find, if order is 5, then maximum key is 4. Then if you insert 9, then it violate the Violate the BC, violate the B tree definition? Yes or no? Violate the B tree definition. Why? Sir, what is the B tree definition? If order is P, then maximum element, maximum keys you can accommodate, that is P minus 1. And minimum keys ceiling function of P by 2 minus 1. So, sir, it is violating the B tree definition. Na? Here maximum keys is that can accommodate, that is 4. But you are inserting 5. So, it violate. Then what we have to do? We have to splitting the node. Because B tree is a tree, B and B plus tree, in which we insert from the leaf and go to bottom to top, you can say. Clear, bacha? So easily you can find the middle element here. If there are 5 person, then easily you can find the middle element. Na? But if there are 4 person, then how can find which is the middle? Which one is the middle? So if we have a even order, like order is 4, then you can't find the middle element, because either 3 could be middle, or 3 could be middle, or 5 also. Either 3 or 5. Now, sir, we have a confusion. Which one we will take? Which one we will take? We can take 3 or we can take 5, sir. Please let me know, sir. So, my dear student, if you take 3, then what is the meaning of if you take 3? What is the meaning? Ki you are taking left hand side very less and right hand side more weightage. Right hand side more weightage, you can see. Right hand side more weightage. Then if you give the weightage to the right hand side, if you are doing the right biasing, then complete question. Sir, it is easy to clear gate. Very good question. Anush, listen beta. Or not only Anush, but just keep 1 minute. Hai na? First of all, explain this topic, then I come to my point. Hai na? So, what I will reply to your question. If it is we are giving the more weightage to the right hand side, then in the complete question means there are so many datas, then complete question you have to do more weightage on right hand side. If we are giving more weightage on left hand side, like this one become middle, then in the complete question you have to give more weightage to the left hand side. This is the thumb rule. Clear, bacha? Seema, Sham, Jaideep, GATE, easy, CSE, Adya Raj, each and everyone. It is easy to clear GATE exam. One thing I am telling, Anush, in the GATE, है ना, what is the subject majorly? C, DSA, discrete, DM बोलते हैं, DMGT, digital, and I know some all subject, but DBMS, OS, COA, CN, TOC, compiler, DA, math, FT. Clear? Now listen, बच्चा, मुझे पता है सब्जेक्टों के नाम. I am writing according to the ascending order in which you will get in your semester examination. So बच्चों, in the first year you will get the C language. In the first year you will get the C language. In the first year you will get the C language. In the second year, maybe second semester also, you will get these 2 subjects. Then second year, fourth semester, you are getting these subjects. One thing, math, you will get first semester. Aptitude, you know. And aptitude portion is completely 15 marks, you know. Math, 13 marks in other branch. But here math plus discrete, DMGT, have a heavy weightage. Okay. Now, Anush, one thing I am telling truth, after 12th, if you have a vision for doing your graduation, you are doing your studies from the IIT, it required 100% efforts. Then after the GATE, after BTech, it required 40 to 50%. Yes, is it true? Yes. If you have a question, is it true? Yes, it is true. Believe me, my dear. Why? Because this subject you done your BTech curriculum also. Sir, वो तो हमने 11th 12th में भी की थी, physics chemistry math. Physics chemistry math we have done in 11th 12th also. Then why? Then what is the difference? Here you become mature. Sir, that time also we mature. Mature means you are able to visualize the things and understanding the things and link also. It's total conceptual paper. Total conceptual paper. Technical concept. That's all. Technical aptitude you can say. So it's very easy, but it required clearing gate is easy. But what about rank? Yes, Baba sir make a one video on YouTube, है ना, सभी के फेवरेट अपने बाबा सर मेक सतीश सर बाबा सर मेक ए वीडियो कि व्हाट इज द डिफरेंस कि हाउ ए स्टूडेंट ओनली स्कोर गुड मार्क्स, वेरी गुड मार्क्स, एंड हाउ टू convert this good marks into rank, how to convert this very good marks into rank also. Because I have very less time today, I have to explain B and B plus 3, that's why I'm not taking. But already at gate wala platform you will get this type of video also. And if you want to ask in a short form, in a summarized way, how to get a very good rank, you can clear the gate exam in a very good manner. Yes, you can get the easily 30 marks, 40 marks also. But if you with the help of BTech knowledge also you can clear the exam. If your BTech knowledge is good, if you read standard books in your BTech curriculum, then you can get the very good marks in BTech gate also, है ना. So but what is the thing required for a gate rank? First of all, discipline and consistency, and all the PYQs, practice sheet, DPPs, whatever materials we provide. If you do each and everything, and not only solving the PYQs, analysis of the PYQs also, then easily you will get the very good rank. Okay bacha. Now I am discussing B tree definition, so we'll discuss if order is P, then what happen? Maximum P block pointer, P minus 1 keys, and P minus 1 read pointer बच्चों. Now I am going to discuss definition of B tree. Definition of B tree beta. Definition of B tree बच्चों. Definition of B tree. Please put your pen down. Really it's very good. You will enjoy. In which first of all I am discussing structure of internal node. Structure of internal node. Yes बच्चों, you know beta, like someone asked to Michael Phelps, है ना, swimmer, you are very lucky, you won this much gold, ye wo blah blah, you are very lucky in this Olympic whatever. Then he give what is the hard work we have done, daily 8 hours in a water, in a pool, clear. And believe me, if you are giving daily 2 to 3 hours from today onwards, although you have to increase your number of hours, but daily 2 to 3 hours you are giving na, with consistency, disciplined manner, है ना, and utilize complete time, that complete time in a productive manner, then easily you will get the very good rank, believe me. But not only 2 hours till the complete exams, you have to increase power of compounding. Structure of internal node, my dear, structure of internal node. If we have order P, if we have order P, then what happen? We have a B1, K1 R1, B2, K2 R2, B3, K3 R3, BP minus 1, KP minus 1, RP minus 1, and BP. And BP. Very good, bacha. So here, this B1 will indicate those element which is less than K1. B2 will indicate those element which is greater than K1 but less than K2. Clear everyone? Each and everyone getting my point? Again I am explaining. Beta, now I discuss B tree. What I discuss? Ki if in a B tree we have a order of P, then maximum we have P block pointer, keys P minus 1, read pointer P minus 1, and minimum keys ceiling function of P by 2 minus 1. Now I will write in a professional manner. If your order is P, if your B tree order is P, B tree of order is P, then what happen? P block pointer, P minus 1 keys, and p minus 1 read pointer. Now I will discuss ki what is the structure of internal node. Internal node block pointer, because here my point is only block pointer. Block pointer. Here the class monitor is, here the CR is block pointer. So B1 indicate those element which is less than K1. Like here you can see B1 indicate those element. B1 indicate those element which is less than K1. Here also you can see B1 indicate those element which is less than K1. B1 indicate those element which is less than K1. B1 indicate or B2 indicate those element which is greater than K1 and less than K2 beta. Clear bachcho? This is the definition of internal node. Now what is the structure of leaf node? What is the structure of leaf node, my dear? Sir, what is the structure of leaf node? Please let me know, sir. Second point is, what is the structure of leaf node? Ki sir, in the leaf node, what block pointer contain? Here block pointer contain null, because in the leaf node it is not pointing to any element, any node also. Clear bacha? Each and every one clear? What I am telling, first of all, what is the structure of internal node? I discuss here now, and so on. What is the structure of leaf node? Third point. Every internal node, please listen carefully and give the answer in proper manner. Every internal node except the root node, contain at least how much block pointer? Tell me, how much block pointer? And at most, how much block pointer? Tell me, bacha. Every internal node except the root. Don't take root. Pravakaran, don't take root. Except the root node contain at least how many minimum keys? How many minimum keys? Minimum keys are, sir, p by 2 ceiling function of minus 1 keys. P by 2 ceiling function minus 1 keys, sir. P by 2 ceiling function minus 1 keys. Yes or no? Then how many block pointer minimum? P by 2 block pointer. What is the maximum? P minus 1 keys. So what is the maximum block pointer? P block pointer. Getting my point? Everyone. Sir, दो भी तो होता है. Sir, 2 is also there ना? That is root. Root contain at least. अरे बच्चा, when it become root, if you have minimum one element, then it become root. One element means one key means what? It required at least 2 block pointer to indicate for left side and right side. Getting my point? So root, my dear, root contain at least 2 block pointer, mean to say minimum 1 keys in root, and at most p block pointer. Yeah, maximum p minus 1 keys. This is the fourth point. And all the leaf node, yeah, keys should be in ascending order. Keys within the node should be in ascending order. Whatever keys we have, that must be in ascending order. And all the leaf node should be at same level, my dear. This is the complete definition of a B tree, order P. Getting my point? If we have a P, order P, then we have a P block pointer, P minus 1 key. Bachcho, if we are getting, then kindly write down in chat box. P block pointer, P minus 1 key, and P minus 1 read pointer. This is the structure of internal node. Key, this denote the those element which is less than K1. This denote the those element which is less than K2 and greater than K1. Getting my point? And BP is denote the those element which is greater than Kp minus 1, my dear. Kp minus 1. Getting my point? Second point I told, structure of leaf node. Leaf node in a block pointer contain null. That not contain anything. And internal node, I told you beta, what I told you, ki in a root we have a minimum 2 block pointer and P block pointer in a root. And in a internal node, what happen? Minimum P by 2 block pointer and maximum P block pointer. P by 2 to P block pointer. This is the third point I told. Then root, parent, yeah, root, not parent, root. Minimum we have one node na, one key na. Minimum we have one key na. So one key means what? At least 2 block pointer are required. And maximum how much? P minus 1 keys means P block pointer. This is the fourth point. Fifth, keys should be in ascending order. Mean to say, like you not observe, I have written here 1 5 3, but when I insert, I shift it, I sort it. So keys always in ascending order. 1 3 5 7. If we have unarranged, you have to arrange in the time of insertion. Getting my point? So keys should be in ascending order and all the leaf nodes should be at same level. You can see here all the leaf node are at same level. All the leaf node, because B tree, as the name indicated, is a balance. Otherwise what happen in some trees? Ki this is the leaf, this is the leaf, this is the leaf, this is the leaf, this is the leaf. You have unscattered way, unmanaged. So B tree is a balanced tree in which all leaf node should be at same level, because it insert from the leaf. Then if violate the definition of B tree, then split middle become the parent or root. And same thing apply for each and every node. Clear everyone? So this is about the B tree definition. If your order is P, then what happen? P block pointer, P minus 1 key, P minus 1 read pointer. This is the capacity of B tree. Capacity of B tree. What? If order is P, then it contain P block pointer, P minus 1 keys, P minus 1 read pointer. That all things must be accommodated into one block. That is less than equal to block size, my dear. Clear, bachcho? Here, BP is what? Block या child या tree या index pointer. RP is what? Record या data record, data read pointer. K is what? Search key या only sometime it is say key. P is what? Order. These are the terms. If order is P, then all things p block pointer, p minus 1 key, p minus 1 read pointer, that all must be accommodate into one block size if order is p. For example, if I am saying order is 5, order is 5, order is 5, and block size, generally block size is 512 1024, but if it is mentioned consider, then you have to do the consider and solve the question. So here beta, if order is 5, then whatever getting you are getting, assume order you are getting 20, assume you are getting 20, so 20 block pointer, 15 keys and 15 read pointer. What is the size? That must be accommodated into one block. This is the meaning. Now I know you required some more clarification. That's why I have one numerical, one gate question. First solve this gate question. Listen, first of all, here I am telling B tree. This question I am drawing. Here order is tree. Here of order 3 beta. Here order is 3. बच्चों यहाँ तक clear है? Well understood. Thank you. God bless बच्चा. If order is 3, then maximum block pointer is 3 and keys is 2, my dear. So what I will do, first of all, I will insert 5, then 8. When I insert 1, then what happen? It become 1, 5, 8. Middle with 5. So 5 is the middle. Seema, Sham, Jadip, Adyaraj, each and every one. Here you are getting 1. Here you are getting 8. This one done, this one done, this one done. 7. Where you insert the 7? Where you insert the 7? Where you insert the 7, my dear? 7 will be insert. First of all, check. Ki it is greater than 5. Yes. And less than 8. So here you will insert 7, then 8. This one done. 3. First you go here, then check. Here you will insert 3. Now 12. Where the 12 will be insert? 12 will be inserted at this point. 7, 8, 12. 7, 8, 12. So what happened beta? What happened? 7, 8, 12. Seema, Gate EG, CSE, are you getting how to insert a B tree? How to create? 7, 8, 12. Then 8 become the middle element. So what we are getting? Here we are getting 5, 8. Here we are getting 1, 3. Here we are getting 7. Here we are getting 12. Clear बच्चों? Easily you can relate beta. This is K1, K2, this is B1, B2, B3. So B1 denote those element which is less than K1, B2 denote those element which is greater than K1, K less than K2. B3 denote those element which is greater than K2. So we insert this one also 12. Now 9. 9. First of all 9 is insert here because greater than 8. Then 9. Here I not erase. Here you will insert 9 and 12. Getting my point? Then 6. 6. Where you insert, this is not this here. Here you will insert 6 and 7. Clear bacha? Now here I draw this B tree also. You can see 5, 8, 5 and 8. Here you are getting 1, 3, 6, 7, 9, 12. You can see 1, 3, 6, 7, 9, 12 and 5, 8. You are getting in this manner. Clear beta? Prabhakaran, Seema, Gate EG, CSE. This is the example of Navathe book. है ना? Standard book example this is. So don't worry. So what is the this dot? This dot denote to the tree या node pointer. This is what? Data pointer. Key with data pointer pair na. And This is called null. Null बच्चा. This is called null. Getting my point? So we create a B tree for these things. So B tree I told already कि which is structure of internal node. X denote B1 denote the those element which is less than K1. B2 denote the those element Seema, Adya, Prabha, KTG, CSE, Ankur. Each and everyone acknowledge fast, my dear. बच्चों today I have a headache. Please acknowledge fast, everyone. So B2 denote those element which is greater than K1, less than K2. Similarly, BP denote those element which is greater than KP minus 1. Third internal node except the root node at least बच्चों at least P by 2 child pointer with P by 2 minus 1 keys and at most P block pointer या P minus 1 keys. Root can be at least 2 child pointer with 1 key and at most P child pointer with P minus 1 key. Every leaf node should be at same level and keys within the node should be in sequence in increasing order. This is the concept, bacha. Like here order is 25. Order is 25. So middle will become 13 will become parent, and here you will get 12. After that here you will get greater than 13, 14 to 25. Now please solve this question, bachcho. Solve this question. Each and everyone, Seema, Adya, Prabha, everyone solve this question, please. Tell me fast, what is the answer, beta? See, देखिए बच्चों, here it is mentioned, what is mentioned, consider a table T in a relational database. A B tree of order P is used to structure on K, where P denote the maximum number of tree pointer या child pointer. Assume key is 10 byte. Key is 10 byte. In this one beautiful concept, bacha. Key is 10 byte and block size 512 byte, and record pointer, that is called data pointer also, is 8 byte, and block pointer is 5 byte. Block size is how much? 512 byte. So you know, if order is P, then P block pointer, P minus 1 keys plus P minus 1 read pointer, that is less than equal to block size. Clear? Now listen carefully. P block pointer, P into 5, P minus 1 8, P minus 1 10 less than equal to 512. 5 plus 8 13. चलो पूरा ही लिख देता हूँ. 8p minus 8 plus 10p minus 10 less than equal to 512. कितना आया? 23p minus 18 less than equal to 512, 23p less than equal to 530. When you take p, you are getting 530 divided by 23, you will get 23.04. So beta, you will take floor value. Why? Although 24 is also in option, it is not there, but if 24 is also there na, if 24 is also there, then you can't take 24 also. Why? Because if we take 24, p equal to 24, and then put the value of order p 24, then it exceed by block size 512 byte. Are you getting my point? What I want to tell you here, bacho, if you take 24, then you insert in this. If you take the order value of 24, then you insert here p value, 24, then you are getting greater than 512 bytes. Means that means you cannot accommodate in a block if order is 24. Are you getting my point? Because that all things must be accommodated in one block. Clear bacha? What is the reason, bacho? Reason is very important ki why we are doing, why, what is the reason for this. Each and everyone chamka. So this is my B tree beta. I told already B tree. Now we are going to discuss B tree suitable for random axis. Random axis not suitable for range query like 830 se bada, 85 se chota. Then B plus tree we have. After that B plus tree. So Seema, it is crystal clear for you? Everyone, Seema, Prabha Khan, Gate Easy, CSE, each and everyone let me know fast. Now in a B tree and B plus tree, I am telling in shortcut manner, there are three difference, B and B plus tree. Majorly three difference. Plus ka nahi? Three difference. First of all, I am writing in non-technical manner. What is the three difference? First of all, pehla difference, internal node, no read pointer. Mean to say, in an internal node, my dear, in an internal node we have a keys and block pointer. Keys and listen. In an internal node we have a keys and block pointer. मैं वेट कर रहा था, आप लिख दो जल्दी से, पर आपका चैट बड़ा स्लो है यार. हाँ, in the internal node no read pointer, no read pointer. First point, in internal node we have a only keys and block pointer. Second point, all keys are available at leaf node. Mean to say, wahan here we find this condition na, like 3, here you getting 5, 1, here you getting 5, but here 3 could be present either left side and right side. Key must be available in leaf node. Key must either here or here. 3, 5. Clear bacha? And third point, leaf node contain keys and read pointer and one block pointer. In the leaf node, beta, what happen? We have a keys K1 R1, K2 R2, and read pointer. Why? Because all the keys are available on leaf node, so there is a no need of read pointer or record pointer in an internal node. Why it is not needed? Because we already copied down all the keys on leaf node. Clear bachcha? K4 R4, KP minus 1, RP minus 1, and one block pointer, only one block pointer that connect with the next node as a linked list, wala concept. Are you getting my point? So this is the three difference in the B and B plus tree. Now listen carefully. Again I am telling here what I am telling. In the internal node, please listen, enjoy only. In the internal node beta, internal node, in the internal node we have a key and block pointer, like you can see tree pointer and B1 K1. Here I am saying P1. This KP minus 1 BQ BP, P block pointer and P minus 1 keys. But but in the B tree, second difference, in the B tree we find the less than. Here we find the less than and equal. Less than and equal, either left hand side or right hand side. Second, on a leaf node, what you have? You have a key and read pointer, and only one block pointer that point to the next leaf node. This is the point. Getting my point? So leaf node, and I told here, listen, order P, then maximum possible pointer that can store. Leaf node we have a keys and read pointer pair plus only one block pointer. Only one block pointer you can see. But in the internal node, keys and block pointer or child pointer, but no record pointer. Getting my point? So directly, and what is the meaning of left biasing and right biasing? I already told you. If you are giving the more support on left side, that is called left biasing, and if you are giving the more support on right hand side, then it is called right biasing. It's similar like your father do. Sham, similar like Sima, your father do. Me also doing with my kids, like your father love the daughter, है ना, as compared to son, and your mother love the son as compared to daughter. Please listen this disclaimer. This is happen only with me. I don't know if it is happen with you or not. I favor my daughter as compared to my son. Getting my point? So what I am saying, this is suitable for range query beta. Now this is the question, but before this question I am telling, if I am asking about the internal node, then what is the formula for internal node? What is the formula? What is the formula for internal node? P block pointer, P minus 1 keys less than equal to block size. It's very simple. Or if I am asking about the leaf node, then what happened beta? What happened? P minus 1 keys plus record pointer pair. Getting my point? P minus 1 keys and record pointer pair plus one block pointer less than equal to block size. If block pointer order is P. If block pointer order is P. Clear? Now solve the question. This is asking gate. This is asking gate beta. Gate 2 marks. Each and everyone do it fast. जल्दी कीजिए बेटा, fast. Everyone. So here internal node is given. You can directly apply P block pointer, P minus 1 keys less than equal to block size. So P block pointer size is how much? Child pointer या block pointer is 6 byte, and keys search key field value is 14 byte less than equal to 512. 6P plus 14P minus 14 less than equal to 512. 20p less than equal to 526. So p 526 divided by 20, 26.3. You will take 26. Are you getting beta? Shyam, Seema, Jaideep, Adya Raj, Prabha, Anubhav, Amul, Prabhakaran. Getting beta? Now, next. What is mentioned? कि in a B plus tree. बच्चों, these two definitions are different. These are the difference in a B and B plus tree. Remaining third, fourth, fifth, sixth point are same. Only internal node and leaf node point are different. Remaining structure are different from B tree. But but my dear, but third, fourth, fifth, sixth point same. Third, fourth, fifth, sixth point are same. Now you forgot na ki what is the third point, what is the fourth point, what is the fifth point, what is the sixth point. I am telling. Third point is what? P by 2 to P block pointer. If you remember, minimum to maximum. Fourth point, root 2 to P block pointer. This is minimum, this is maximum. Keys in ascending order. If you remember beta, अभी याद हो जाएगा. And leaf node at same level. So my dear, these 3, 4, 5, 6 point is same as B tree. Clear बच्चों? Same as B tree. Now solve this one. Then we are going to revise each and every point. Then we wind up. Don't worry about that. I will not take so much time. Please do it fast. In the last, I will talk to you. Yes, Seema, be present till the last. Seema, Prabha, Gate EG, CSE, Adya Raj, Jaideep, those are listening. Listen. Here, what is mentioned? Maximum number of keys is 5. Maximum keys is 5. Maximum keys is how much? That is equivalent to P minus 1. Na? So P minus 1 equal to 5. So P equal to 6. Mean to say order is how much? Are you getting 6? Order is getting 6. Then what is the minimum number of keys? P by 2 minus 1. Getting my point? So 6 by 2 ka floor, sorry, ceiling minus 1. 3 minus 1, 2 beta, 2. Clear? So tell me fast. Any doubt? My dear student, my dear lovely student, any doubt? Once again, I will revise each and everything. What we done, we discuss FD and normal form. Beta, please put your pen down. Put your pen down, everyone. We discuss FD and normalization. What are the topic we done in these 33 classes? FD and normalization, transaction and concurrency control, and ER model and foreign key concept या referential integrity concept. Then query language, After that, file organization and indexing, my dear. File organization and indexing, my dear student, whatever important na I have taken in these lectures, although these lectures, believe me, I planned for a 22 lectures, maximum 22, because due to shortage of time and due to other schedules. But believe me, when I asked to the PW, ki yes, can I take more, because I'm not able to complete even more important topic, I'm not able to complete. Then they say yes, then I am giving to each and every concept. Believe me, some very beautiful concept like chase test, partial dependency concept, you read. I'm not saying you read correct or wrong, but please watch that videos, that will help you. Otherwise you will do the wrong in the gate exam, है ना. Second point, each and every concept, whatever important point, I am trying to cover and covering each and everything here. So बच्चों, you tell me, Seema, Gate EG, CSE, Sham, Jaideep, Adya, Raj, Prabha, so you enjoy this series, you enjoy this series, tell me fast, you enjoy. Every concept is crystal clear in DBMS. Expect convert to ER diagram to relational model. Beta, Gate EG, CSE, it's, I agree, it's a mutual fault. Not only my fault, it's your fault also. When I was revised, because you know there is a alternate classes. We taken the class on Friday, then on Monday. So I think yes, we have covered. But in the beginning when I was asking, you say no. But don't worry, you already have that concept in PDF. I upload that PDF on that particular lecture you have. In the next, when I will teach DBMS in a crash course also, in a Hindi platform also, then I will again explain this. I will give more focus on this also. It's my promise. So that time you no need to watch any, and this is happened before GATE 2024 video, exam. So I promise you no need to watch complete series. That you can only watch that video only. You will get the topic on thumbnail. No doubt, enjoy fully. Yes sir, enjoy. Believe me, I am trying, not say ki I have taken complete, because this is a complete COA. No. Right now, I have in a batch, another classes in paired batches. So whatever the next information you will get, next subject, believe me, if I am saying ki I have taken complete, so it is not possible, because some concepts are good in this book, some concepts are good in fourth book, some concepts are good in Navathe book, and some concepts are very good in Ulman book also. So bachcho, whatever I can give in this short period of time, I am trying to cover, bacha. And believe me, although I am not saying I have taken complete covered, because I can teach this DBMS more than 100 plus hours. So, but whatever is important, whatever is beneficial for you, now you can read it, you can solve, you are able to solve each and every question. And something, if you, I not explain, but you are able to connect. That is my promise. So thank you bachcho. God bless you everyone. Thank you. Thank you. And अगर मैंने किसी को डांट दिया हो, प्लीज डोंट माइंड, है ना, डोंट माइंड. एंड बिलीव मी, you enjoy this concept, and try to solve the PYQs also. Try to solve the PYQs also. And in these all sessions, I never ever doing any marketing activities, not any promotional speech. Don't waste your any single minute, 10 minutes, 15 minutes to do the promotional activity. No bacha. Yes Seema, we will do for that, don't worry, and you will get that information also. Right now we have a Telegram channel for Gate Wallah, you can join, you will get that information on that channel. Okay, Telegram channel. So here I'm trying to do only complete study. Don't waste your single minute. Sometime 1 minute, 2 minute motivation, that is okay, but not doing any promotional or marketing activity. Only concept here. Okay, I'm not comparing with anyone, but my objective is clear. Ki please you read it, and read. If you are not able to read the book, at least solve the PYQs. While you solving the PYQs, then you will get the very good varieties of questions also. So thank you everyone. Thank you. God bless you everyone.